Okay, what we're going to do is we're just going to go over Lewis structure again and remind you what they are and how we get them. Okay, remember Lewis structure is a way of representing the covalent bonding of a compound, where we show bonds as a line and we show lone pairs as dots. Okay, and when we're doing our Lewis structure, we have two types of electrons. Those that are involved in bonds, which we call bonding pair electrons, and those that belong only to one element, which we call lone pair. Remember, when we're doing this, we want to determine our total number of valence electrons, and we'll add for minus charges and we'll subtract for positive charges. We'll put the least electronegative, or the one with the highest bonding capacity, in the center. The others around. We'll add a single bond, subtracting from the total. Place lone pairs around. Then we'll add our lone pair electrons so that our peripheral atoms all have an octet. Then any extra electrons after the peripherals all have an octet go in the central atom. So the central atom is lacking a full valence energy level. Then we'll move lone pairs to give it double or triple bonds. And if it's a polyatomic ion, it goes into square brackets. So for example, if we look at OF2, okay, we're going to look at our elements. We have oxygen and fluorine, and we look at the number of valence electrons. Remember, it can be gotten from the group. Okay, and we'll add those up. Now we know both elements present require 8 electrons to fill their valence. So we get our total electrons that we require. We can get our number of bonds, our required minus our half divided by 2. And we can get our number of lone pair electrons. So now we know that we have 2 bonds and we'll have 16 lone pairs. Okay, now oxygen is going to be our central atom because it is the lower electronegative, plus it can form the most bonds. Fluorine can only form 1 bond, whereas oxygen can form 2. So we're going to write our central. We're going to put our 2 peripheral atoms. We're going to add lone pairs, our bonds, and then we'll add our lone pairs to our peripheral, and then we'll add the remaining to our central atom. So now some atoms require fewer than 8 or more than 8. Okay, and if they need fewer than 8, we say that it's a compressed octet. And for us, the ones that require fewer than 8 are beryllium or boron. And the ones that require more than 8 and have an expanded octet will be phosphorus or sulfur. So like we did before, we identify how many valence electrons we have. In this case, we're adding 3 electrons to our total from our elements because we have the -3 charge. Then we're going to determine the amount that they each need. We're recognizing that boron only requires 6. It doesn't require 8. Then we can get our number of bonds. We can figure out our lone pairs. Okay, now we know boron is going to be our central atom because it's the lower electronegative, plus it has a bonding capacity of 3. Oxygen only has the bonding capacity of 2. So we'll put our central atom with the others around it. We'll add our 3 bonds, and then we'll add our lone pairs. Now we won't give any more electrons to boron, even though it only has 6, because it only needs 6 to fill its valence energy level. And then we'll put it in square brackets.